Let's work on NJC 2023 Prelim Paper 2, and more specifically, let's take a look at the statistics portion of this paper. So let's go to section B. Section B, here we go. Here. So in section B, question number 6, we are given X as one that follows a normal distribution with a mean of mu and a variance of sigma square. In part A, we are supposed to evaluate the probability that is given to us. It is the probability when X is bigger than mu plus 0.05 sigma. Because we don't know what is mu, we don't know what is sigma square, so there is no way for us to press into our calculator directly. But what we can observe from here is the possibility of rearranging what we have within the bracket into one that we can simulate a standard normal distribution. And if I were to look at the standardized version of this, we are talking about X minus mu divided by sigma, which will then follow a normal distribution of 0, 1. And this is Z. So let's try to see whether we will be able to create this within what we are trying to calculate. So if I were to bring mu over to the left hand side, we have X minus mu, and this is bigger than 0.05 sigma. Sigma, which is the standard deviation of X, it is an always positive value. So I can divide it across to the other side of the inequality without swapping the inequality sign. So this will be the probability of X minus mu divided by sigma. This is bigger than 0.05. So what we have here is Z, that is going to be bigger than 0.05, and Z, which is a standard normal distribution, follows a normal distribution of 0, 1. We can now press this into our calculator, and this will be giving us a 0.480 to 3 significant figures. Let's take a look at part B. Part B, we are given that the mean of a random sample of n independent observations of X is denoted by X bar. So X bar is going to be equal to X1 plus X2 all the way until Xn divided by n. And because X is already following a normal distribution, so if I were to combine this together, making use of what we have learned in sample mean distribution, this will follow a normal distribution with the mean of this to be exactly the same as the mean of X. So it will be mu, and for the variance of this, it is going to be with reference to sigma square, but it is going to be sigma square divided by n. And the question says this: we are supposed to find the least value of n such that the probability of X bar differs from mu by at least 0.05 is at least 0.4. So for my interpretation, we are talking about X bar differs from mu. So the word differs tells me that we will need to look at the difference between X bar and mu, but we don't really know which one is bigger. So we're going to add a modulus to this to improvise and interpret what the question is saying. And this differs by at least 0.05 sigma. So this is going to be at least 0.05 sigma, and this probability is less than 0.4. So here, less than 0.4. So we are going to try to find, according to what the question says, the least value of n, such that this inequality is being satisfied. So I guess what we also will need to do, since we don't have a lot of numbers that are here, we will also try to use the same strategy as this to try to get a standardized version for X bar. And to standardize X bar, it is going to be X bar minus its own mean divided by its own standard deviation, which is going to be the square root of this. So it's going to be square root of sigma square over square root of n. So it is going to be reduced to sigma over square root of n. Okay, the square root of this. This will then be equal to z, which will then be 0, 1. Let's try to see whether we will be able to create a version of this here. So we already have an X bar minus mu, which is this. What we need to do is to divide this entirely by sigma over square root of n, which is the standard deviation of x bar. And sigma over square root of n is going to be a positive number, so we can just divide it across the inequality within the probability without affecting the inequality notation. So it is going to be probability of modulus of x bar minus mu divided by this, which is going to be square root of sigma square over square root of n. So we will have this. So it's going to be sigma over square root of n. And because it is a positive value, so I'm going to just bring it into the modulus notation anyway. This is going to be bigger or equal to 0.05 sigma divided by also sigma divided by square root of n. This is supposed to be less than 0.4. So what we have here is going to be a modulus of z, the standardized version for x bar. And on the right hand side, it is going to be 0.05. Sigma can be cancelled, so square root of n. So this is going to be less than 0.4. So for what we are looking at here, this part. Okay, on the left hand side, we have probability that modulus of z is going to be bigger or equal to this, which means that we are looking at the probability of z to be less than or equal to minus 0.05 square root of n, or the probability that z is going to be bigger or equal to 0.05 square root of n. And if I were to imagine this on the bell curve, then what we are going to be expecting, the bell curve for z, so here, z, the middle here is going to be 0. We are looking at the region that is on the left-hand side of this number, and also the region that is on the right-hand side of this positive number. So we are looking at this region here, okay, where this value is this, and this other value is this. So we can definitely replace this with this, which is totally fine, or we can also do a small little improvisation by taking 1 minus this region, 1 minus the probability that z is between this and this. So I'm going to do that. This seems to be a little bit more like smoother in terms of my solution. So it's going to be probability that z is between negative 0.05 square root of n, and I shouldn't need an equal sign anymore. So this less than 0.05 square root of n. This is less than 0.4. I'm going to do one more improvisation, which is to bring everything over to the left-hand side so that I'm going to be comparing to 0. So for what we have here, if I have to bring this over to the left-hand side, we will have a 1 minus 0.4. So this will be 0.6 minus probability of minus 0.05 square root of n. And z is going to be between these two, 0.05 square root of n. This is less than 0. And in order for me to solve for the least possible value of n, I'm going to use my graphing calculator and using the table feature to try to find the least possible value of n. So in my calculator, I'm going to be pressing this line into y1. So y1 will be pressed as 0.6 minus this, which we are going to be making use of normal CDF on our calculator. So if I were to press for normal CDF, it will be asking us for the lower limit, and that I'll press it in as minus 0.05 square root of x. Then it will ask for the upper limit. It will be 0.05 square root of x, which is this. It is going to be asking for mu, since we are using z. So z follows the normal distribution of 0, 1. Mu is going to be 0, and sigma is going to be square root of 1, which is still 1. I'll paste this into my calculator, into my y1, then we will generate a table. Let me reproduce the table here in my solution. So in my table, we will have x, which is going to be representing n, and y1 will be this entire string over here. So it's going to be 0.6 minus the probability when z is between this 0.05 square root of n, 0.05 square root of n. scrolling down the table for quite a while until when n is 283, we will see this to be 2.7 times 10 to the power of minus 4. So I'll probably use a bit of the table set button on my calculator so that I can go further down the row of tables that I have. So here, this is negative 6 times 10 to the power of minus 4. This is when this starts to become less than 0. And when it is 285, this is negative 0.001. So this is going to be the least possible n when this is going to be less than 0. That is why for this part of the question, the least n is 284. Let's take a look at C, but let me erase the board first. So for part C, we are now going to be looking at yet another random sample of m independent observations of x. And the probability of at least 4 of these observations exceeding mu plus 0.05 each is at most 0.95. This is given to us by the question. We are going to find the greatest possible value for m. So for a scenario that is like this, if you were to try to associate it to distributions that we have learned in our syllabus, this is actually a binomial distribution. And I'm going to define my random variable to represent this particular binomial distribution. I'm going to go for y. I'm going to let y be the number of observations of x. And we are specifically interested in those observations when x exceeds mu plus 0.05 sigma. And this is going to be done out of m observations of x. So y here will follow a binomial distribution. Out of m observations of x, the probability of success is for x to be more than exceeds mu plus 0.05 sigma. So we have already calculated the probability here. This we wrote down by rounding this off to 3 significant figures. So I'm going to take this value, but the 5SF value instead of this. So that will be 0.48006. And the question says that the probability when y is bigger or equal to 4, this has to be less than or equal to 0.95. And we're going to be making use of this inequality to find the greatest possible value for m. So I'm going to use binomial CDF, which require the inequality that is within the probability to be less than or equal to. So I'm going to rewrite this. Since we want 4, 5, 6, and so on, I will do a 1 minus probability that y is less than or equal to 3. Then I will be getting 4, 5, 6, and so on. And we want to make sure that this probability is less than 0.95. And from here, we are going to just try press this directly into our graphing calculator. And we are going to use table again, just like what we did in part B. So I'm going to press this into y1. It will be 1 minus, we are going to be using binomial CDF. So if I were to be using binomial CDF, they will be asking us for the number of trials. In our case, the number of trials is unknown, so we are going to be putting in an x. The probability of success is this, 0.48006. And we are going to be asked for the x value. X value is going to be equal to 3. So 1 minus this, I'm going to press this into my graphing calculator. And from my calculator, this is the table that we are going to be getting. X will be representing m, and y1 will be representing this 1 minus the probability that y is less than or equal to 3. So scrolling down this table, when m is 12, here is 0.9057. It is still less than 0.95. When it is 13, this is 0.9382, still less than. But when it is 14, here we are going to be getting a 0.9601. So it's going to be starting to become more than 0.95. So the greatest possible m, greatest m is going to be equal to, in our case here, 13. Okay, this is 6. Let's move on. Let's take a look at question number 7. Okay, let's take a look at question number 7. So in question number 7, we have the Ang family. There are 3 members in the Ang family, Bao family, 5 members, and then Chu family, 4 members. And for these 3 families, they are going to be invited to this wedding dinner. And due to the constraint of the venue, only 2 members from each family can attend this wedding. So part A, we are going to find the number of ways to be selecting these 6 attendees. We need 2 from each family. So from the Ang family, there are 3 from Ang family. We are going to be choosing only 2 of them. 5 members of the Bao family, we are also going to be choosing 2 of them. 4 members from the Chu family, choosing 2 of them. Multiplying this, it is going to be equal to 180. This is part A. And these 6 attendees, they are going to be randomly arranged to sit at a round table. We want to find the probability. Okay, we were doing P&C here. Part B, let's make sure that we are focused on what the question is telling us. So we are looking at the probability. So we want to find the probability that 2 members from the Ang family are not next to each other. So in part B, in order for me to make sure that 2 members from the Ang family are not next to each other, we can either do slotting, or we can also try to do a complement. Since if I were to take 1 minus away the probability where just the 2 members of the Ang family are together, that will already make sure that we are working on probability of them being apart. So it is going to be 1 minus away this scenario. The Ang family together, and for the rest, 2 from Bao, 2 from Chu, they can be sitting anywhere. So the probability will be 1 minus away. The number of ways to be arranging this, it is going to be treating this as one object. We have 1, 2, 3, 4, 5 around the circle. So 5 minus 1 factorial. 2 from the Ang family, they can switch positions. So 2 factorial. This is probability, so we will divide by all the possible ways that these 6 people can be arranged around this circle table. So it will be 6 minus 1 factorial. The probability of this, if I were to calculate, this is going to be equal to 3 over 5. C. Now the host decides to change the layout of the venue to accommodate more people so that a total of 7, actually just one more person, so a total of 7 people can now attend the dinner. And part C, let's see. For part C, we want to find the number of ways to select 7 attendees with at least 2 members from each family. And what I'm going to do is I'm going to work on this by looking at 3 different scenarios, 3 cases. The first scenario, where to ensure that there are at least 2 members from each of the family, we will go for the Ang family having 3, then the Bao family 2, then the Chu family 2, C. And I can think of another case where at least 2 members from each family must be present, which is to have 2 from Ang, 3 from Bao, and 2 from Chu. The last case, I think this is now even more obvious. 2 from Ang, 2 from Bao, and 3 from Chu. To calculate this, there are 3 members from the Ang family, we are going to choose all 3. 5 members from the Bao family, we're going to choose 2. And 4 members from the Chu family, we're going to choose 2. This is going to be equal to 60. This. Out of 3 from Ang, we're going to choose 2. 5 from Bao, we're going to choose 3. And 4 from Chu, we're going to choose 2. This is equal to 180. 3 from Ang, we are going to choose 2. 5 from Bao, we will choose 2. And 4 from Chu, we are going to choose 3. And this is equal to 120. So the total number of ways will be equal to 60 plus 180 plus 120. And this is equal to 360. This is for part C. Let's work on the last part of this question, part D. Part D, the 7 attendees selected. So it is already selected. Okay, we don't have to reselect them again. So it is selected, which means that there should be at least 2 from each of the family. And these 7 attendees are going to be now seated in a row for photo taking. We want to find the probability. Okay, now we are switching back to probability. We want to find the probability that the people from the same family are seated together. So what we will be expecting is for one of the families to have 3 and the other 2 families to have 2 members in this 7 attendees. So the first family that has 3, they are going to be seated together. The next family, which has 2, they're going to be seated together. And the last family, which has also 2, they are also going to be seated together. And we just want to make sure that we also recognize that this, although they are 2 groups of 2, but they are distinct groups of 2. Okay, they are going to be from different families. So what we are looking at here is 1, 2, 3 different objects or different groups. So it's going to be 3 factorial. Within this group, there are 3 members. So 3 factorial, this, 2 factorial, this, 2 factorial. This is a probability, so we want to divide by all the possible ways that they can be arranged in a row for photo taking. So divide by 7 people factorial. This, if I were to press it into my calculator, this is going to be giving me a 1 over 35. Okay, this is 7. Let's move on. Let's take a look at question number 8. Now let's take a look at question number 8, where we are given 3 events, A, B, C. The probability of A, this is given to me as 0.1. The probability of B, this is given to me as 0.2. And the probability of C, this is given to me as just C. A and B, they are independent events. A and C, they are mutually exclusive events. Part A, we are going to state the values of the probability of A given B. And since A and B, according to what the question says, they are independent, so the probability of A given B is the same as the probability of A, so this is 0.1. We want to also state probability of A given C, and this is probability of A and C divided by probability of C. And the question says that A and C, they are mutually exclusive. So the probability of A intersect C is going to be equal to 0. The probability of C is going to be C. This is still going to be equal to 0. This is for part A. Next, it is given to me that probability of A union B is equal to probability of A prime intersect C prime. We are going to make use of this equation most likely to find C in part B. So the first thing that I am going to try do is to calculate for probability of A union B. Probability of A union B, we're going to use the formula that we have learned since our secondary school. It is going to be probability of A plus probability of B minus probability of A intersect B. And because the question is telling us that A and B are independent of each other, so probability of A intersect B is probability of A multiplied by probability of B. So this will be 0.1 plus 0.2 minus away 0.1 times 0.2. And this is equal to, if I were to press it into my calculator, this is equal to 0.28. Let's also try to look at probability of A prime intersect C prime. A prime intersect C prime. And to calculate this, I guess we can definitely take a quick look at the Venn diagram to see how this region can be represented on the Venn diagram. So if I were to be looking at AC, they are, according to the question, mutually exclusive. So they will not be overlapping. A here, C here. So we are looking at the region that is outside A and outside C at the same time. So it's going to be this. So for this region, what we are going to do is we are going to just simply take 1 minus away the probability of A and the probability of C. So PA minus PC. And this is equal to 1 minus 0.1 minus away PC, which is going to be just C. So here we have a 0.9 minus C. And the question says this is equal to this. So it means that 0.28 is going to be equal to 0.9 minus C. And from here, we will be able to solve for C. C is going to be equal to 0.62. Let me just fill this in for here. So now we have found this as 0.62. We have one last part, part C. So for part C, let's take a look at what the question requires. We want to find the maximum and minimum possible of that probability. And we are going to try to have a better understanding of this probability by drawing a representation of it on a Venn diagram. I am going to draw it here. Let me try. We are going to have A here. We're going to have A overlapping B. So we will have this. And for C, C cannot be overlapping A at all. So I'm going to draw C here. Something like this. And this will be within the universal set. So this will be A, this will be B, and here we will have C. We are going to be looking at probability of A prime intersect B prime intersect C prime. The region that is outside A and outside B and outside C at the same time, which is this whole region that is outside. And I'm going to call this region X. So we're going to try to find the maximum and minimum possible of X. And what I'm going to do is I'm going to fill in all the regions here with numbers and probability, and probably also with association to X. So for example, this region is probability of A intersect B. So it's going to be probability of A times probability of B. It is 0.1 multiplied by 0.2. So this region here is 0.1 multiplied by 0.2, 0.02. And since PA is equal to 0.1, so taking 0.1 minus away 0.02 will give me this region. So this is going to be equal to 0.1 minus 0.02. This gives me a 0.08. Let's think. Let's see which other regions we can actually try to fill in. We know that probability of A union B is 0.28. So this entire region here is 0.28, which means that this will be 1 minus away X minus away this 0.28. So 1 minus away X minus away 0.28. This is going to be giving me a 0.72 minus X. So here, 0.72 minus X is going to be this region. What else? What else can we find? I guess this. Because this region, since we have now C as 0.6, so it is going to be, 0.62. So it will be 0.62, this entire thing, minus away this. Minus away 0.72 minus X. And this is going to be giving me a this is going to be giving me, this is going to be giving me an X minus away 0.1. So here, X minus 0.1. And I guess one last region that we can fill will be using 0.2 minus away this, minus away this. So 0.2, which is going to be the probability of B, minus away this, minus 0.02, minus away x minus 0.1. And this is equal to 0.28 minus away x. So here, 0.28 minus x. Okay, now we have filled in all the possible regions that we have, and we are going to extract out all those that are related to x. Because all these are probabilities, which means that the most generic range or generic condition that they must each satisfy will be for them to be between 0 to 1. Probabilities, they must always be between 0 to 1. So let's try to write down all these conditions, and from here we are going to work out the maximum and minimum x, which will then give us the maximum minimum of probability of A prime intersect B prime intersect C prime. So first of all, this x must definitely be between 0 and 1. Let's move on to the next region. Let's say this region. So this region, 0.28 minus x. This will also be between 0 to 1. And if I were to manipulate this inequality, I'm going to be getting x to be between minus 0.72 and 0.28. Next, this region, x minus 0.1 should also be a number that is between 0 to 1. So if I were to manipulate this, I'm going to be getting x to be between 0.1 and 1.1. And finally, this region, so that will be, for this region, 0.72 minus x to be between 0 to 1. And for this region, if I were to manipulate this inequality, I'm going to be getting a negative 0.28, and x is going to be bigger than this and smaller than or equal to 0.72. So based on what we have here, we know x must be bigger than 0, it must be bigger than this, it must be bigger than this, it must be bigger than this. So the smallest x can go will be 0.1. X must be less than or equal to 1, less than or equal to this, less than or equal to this, less than or equal to this. So the biggest x can go is going to be 0.28. So therefore, based on this, we can see that x is going to be between 0.1 and 0.28. And this x is representing A prime intersect B prime intersect C prime. So this is between 0.1 and 0.28. And this will then tell me that the minimum possible of probability of A prime intersect B prime intersect C prime, this is 0.1. And the maximum possible of A prime intersect B prime intersect C prime, this is equal to 0.28. Yep, that's it for it. Let's look at another question.
In question number 9, it's believed that the probability of a woman giving birth to a Down syndrome child is related to the woman's age. And this table gives the observed values for P for 5 different values of X, whereby X is the age and P is the probability of the child having Down syndrome. So the data is provided for us. I'm going to key in this entire data into our GC first. Let me bring up the GC. Okay. So under our stats edit, I already key in these values already. For L1 is the X, which is the age. L2 will be the probability that the child has a Down syndrome. I'm going to draw myself a own table for my own reference, because later on the subsequent questions will require us to key in a lot more data. So just in case I've forgotten and lose track of what I've already keyed in. So I'm going to draw myself a tiny table to remind me that L1, L2, L1 I will key in is the X, and L2 will be the P. All right, I'm going to go back to this question. Part 1 says sketch the scatter diagram representing the data and comment if this linear model P equal to mx plus c is a good model for this set of data. All right, so to sketch a scatter diagram, I'm going to make use of our GC again. So from our GC, okay, I'm going to quit first. Okay, and I'm going to press second Y to trigger the step plot. So I'm going to on the first one. So I on already. Okay, then I'm going to key in my X list to be my L1 and my Y list to be my L2. So the independent variable in this scenario will be the age, and the dependent variable will be the probability having a Down syndrome is my P. So my X list will be L1, Y list will be L2. After this, we are going to press zoom 9. So this zoom 9 will give me the scattered diagram. So we're going to plot this graph. So we will try to plot this as accurately as possible. So X will be the age and this P will be the probability. And first data is here, second data is somewhere here, another data point is here, and here, and here. We are going to label the endpoints for this scattered diagram. So for this point, it will be 45, and this is 0.03330. And for this point, it will be 25, 0.00067. Back to this question, it says that we are supposed to comment whether this is a good model. I think we can see that for this display of this scatter diagram, obviously the linear model is not a very good model for this particular case because this exhibits a non-linear relation between X and P. Right, so what we can say that P equal to MX plus C is not a good model as the scattered diagram shows a non-linear relation between X and P, right? Now we're going to continue with part 2. It says that by finding the product moment correlation coefficient for each of these new model, determine which of the following would be an appropriate model to represent the above data. So now we have another 3 additional model. So for model A, we can see that it's equal to P equal to A plus B over X. So this, we need to modify our original data a bit. So for column L3, this is our column L3, we have key in 1 over X, right? This will be the new modified data. So under our GC, let me just bring up the table again. So for under L3, basically, right, if I want to have a 1 over X, I actually enter this. I do a 1 divided by L1, right? Then I enter. That's how I managed to get this row of all this data here. This will be my 1 over X. As for our model B, you can see that P is still the same. The X, the so-called X become e to the power of minus X. So under column L4, I have keyed in e to the power of minus X. So what I did here, I go to column L4 on top. I enter. I press E, so it's second E to the power of minus L1 again. So it's second L1. Enter. That's how I get these data here. Okay, and lastly, right, if the question wants us to have the model C to be equal to ln P equal to A plus BX. So in this case, the modified data is from the L2, right? Because it's the ln P already. So for my calculator here, for under L5, I actually key in a ln. So in this case, I'm going to ln this P, so it's a ln L2. So it's second L2, enter. That's how I get this data. All right, so I'm going to remind myself my L5. Actually, I key in a ln P. All right, this is very useful. So I would suggest you guys during your exam, if you are doing this type of questions, right, it is a good reference if you can just write it down like this. So you will not lose track of what you have already keyed in. Okay, so now we are going to find the PMCC, which is the product moment correlation coefficient for each of them. How I'm going to find it, right? Like for example, for model A, we are going to go to stats. We are going to go to calculate. We are going to use option number 8, although option number 4 is also fine. Let's choose option number 8. All right. So the first model, I want to have like a 1 over x and the p. So we are going to make use of this two. So for the independent variable will be my L3. So that is why X list I key in L3. Y list I'm going to key in my L2. So from here, I can enter, calculate. So we can see that the product moment correlation for this situation for model A is minus 0.76276. Let me just write down here. So part 2, model A. Okay, these are from GC. Model A will be R equal to minus 0.76276. Let me just write down model B, what is the value of R, and model C, what is the value of R also. As for our model B, we can see that we want this and this. So for my calculator, I'm going to change my X list, option number 8. So here I'm going to choose second 4 to go to list L4. Then from here we will calculate. Then we can see in this case is a minus 0.37188. So I'll get a minus 0.3718. It's a 177. Okay, and finally the last one, I want to have like a ln p versus x. So in this case, let me go back to our calculator, stats. Now we go to calculate number 8. So in this case, our X list will still be the first one. So I press second L1. And for this case, the Y list will be second 5. So we will go to calculate. Okay, so in this case, our value of R is 0.99373. 0.99373. So with these values, the question also wants us to determine which is the appropriate model. So a bit obvious that model C will be the best because the absolute value of the correlation coefficient is the closest to 1. So I will just write since absolute value of R is closest to 1 for model C, the most suitable is model C, right? Let's continue with our part 3 of this question. It says that for the appropriate model, calculate the values for A and B. So we are going to use model C already. So for model C, we are going to just use this directly because this is the best model. The R is closest to the 1. So in this scenario, this Y, right, represent our ln P. And this X will represent this X. This is my list 1 and list 5. All right, so we are going to extract out the values for A and B and put into this expression. This will be the so-called best fit line. So from GC again, we can obtain that it will be ln P equal to minus 12.465. All right, it's actually displayed here already. This A is minus 12.465. And our B will be equal to 0.19783. And this case, it will just be a X. So for this situation, I'm going to give the 3SF answer for the values for A and B. So the A will be equal to minus 12.5 and our B is equal to 0.198. For part 4, we are supposed to obtain an estimate of the probability of this 19-year-old woman giving birth to a Down syndrome child. Comment on the reliability of this answer. So we are going to make use of this best fit line that we have obtained previously to estimate the value of my probability given the x is equal to 19. Right, so we are going to sub in 19 into this expression. So we have a ln p equal to minus 12.465 plus 0.19783 times 19. So from here, we will work out that our value of this one is minus 8.70623. And solving for p, I'll get a value of answer of 0.000166. This is a 3SF answer. And we are supposed to comment on the reliability of this answer. And we can see that obviously this is not reliable because what we are doing, we are subbing in a value that is outside the data range because the data range is only from 25 to 45 for the x values. So we can write down our answer as the estimation for this situation may not be reliable because x equal to 19 is outside the data range of x that is between 25, in this case 25 and 45. Let me just write properly. All right, so this will be the presentation of my answer for my part 4. For question 10, we have this factory which produces sausage rolls of a length of 10. The production manager wishes to take a random sample of sausage roll produced by a particular machine for quality control. Part A, state what it means for a sample to be random in this context. All right, so we have already memorized the formal definition of random already. So we are going to rephrase it to fit into the context of this question. So what we're going to write is every sausage roll produced by the machine has an equal probability of being selected in the sample, and each selection should be independent of each other. Independent of each other. Okay, and let me just write down, this is a part A. And later on, the lengths of x of a random sample or 60 sausage are summarized with these two summations. This is the data provided by the question. Part B says, suggest the reason why in this context, the given data is summarized in terms of x minus 10 rather than x. All right, basically, we have to look at the scenario, what we are looking at. We are looking at the sausage rolls of length 10. So we will know that although for different values of the sausage roll being selected, it will actually fluctuate around 10 cm. Maybe a bit plus, maybe a bit minus. But as a whole, we will know that the fluctuation won't be so big. It's just around 10. So that is why it makes a bit more sense to examine the deviation from 10 instead of looking at absolute value. Because by doing so, we can actually minimize our calculation because we will be managing a smaller value, which is always much more better. All right, so we can say something around this line. I would say, since the length of the sausage rolls are around 10 cm, by subtracting the values are smaller and easier to manage and to calculate. Right, and for part C, we are supposed to use the data and calculate the unbiased estimate of the population mean and variance. For part C, to calculate what is my bar x, I'm going to make use of our summation of x minus 10, which is minus 2.5 divided by the sample, which is 60, to add back 10. So basically, this part here, what I'm finding is the mean of x minus 10. But we need to find the mean of x. So that is why after finding the mean of x minus 10, I'm going to add back 10. Right? This is the faster way of computing this. So this will give me a value of 9.9583 to 5SF, and to 3SF, the answer is 9.96. As for my variance, I'm going to use the formula provided from the MF. Let me just write down here. S squared is 1 over n minus 1, summation x squared minus summation x whole thing squared divided by n. So this is the formula provided from the formula list. So we are going to make use of this formula to compute our variance of x minus 10 first, because we are given the data as x minus 10. By computing the variance of x minus 10, in fact, is indirectly finding the variance of x, because we know that for properties of variance, x minus 10, in fact, is the same as variance of x. So that is what we are going to do. So we compute the variance of x minus 10 first, which is 1 over 59, because it's 60 minus 1. Summation x squared is equal to 4.3 minus away minus 2.5 whole thing squared divided by 60. This will give me an answer of 0.071116, and to 3SF is 0.0711. Right now we are at part D. So for part D, we'll be starting to do our hypothesis testing already. So this manager claims that the average sausage roll produced by the machine are shorter than 10 cm. So with this statement, I know probably we are going to perform a one-tail test. Test at 10% level of significance whether the manager's claim is valid. You should state your hypothesis and define any symbols that we use. We are going to do a definition for our mu first. Let mu be the population mean length of the sausage rolls produced by the factory. So we are going to state our null and alternative hypothesis, which is mu equal to 10, and alternative hypothesis is mu is lesser than 10. So we are going to perform a one-tail Z test at 10% level of significance. Right, so in this case, right, if I were to look at this entire information provided for us, we didn't see any evidence that X is a normal distribution. So in this scenario, probably we have to make use of the central limit theorem, because in order to perform the test, our bar X must be a normal distribution. Right, so I will write, since n is large, so in this case, n is equal to 60, by central limit theorem, bar X will be a normal distribution, and under, or I should say under H0, right? Our mean, right, which is a 10, under H0 is 10. And for the variance, right, it will just be equal to this, 0.071116 divided by 60, approximately. Right, so this is my distribution for my bar X. So from here, we can compute using GC our value for P. So this is by P value. Okay, let me bring up my calculator. So I have already kind of keyed in the data already. Let me just go back again. Let's stats. You go to test. So under Z test, you'll be keying in this data. So mu naught is 10. 6 sigma, right, will be the square root of this value. Remember, GC only accept standard deviation. So we need to square root our variance. And bar X will just be equal to this value. And sample size 60, we are choosing lesser than mu naught for one-tail test. Then if we were to go to calculate, it will give us the value for the p-value, which is given to be 0.11290. 0.11290. And we can see that this is bigger than the level of significance. All right, so now we can do our conclusion already. So in this case, we know that we shouldn't be rejecting H0. I'll just continue our working from here. Okay, I will say since p-value is more than 0.10, there is insufficient evidence to reject H0 at 10% level of significance. Okay, the production manager claim is not valid. All right, let's continue with the second part of this question. So second part of this question says that after comments from customer, the production manager wishes to test the mean length of the sausage roll produced by the factory is in fact 10 cm. And another sample of 60 sausage rolls is taken. So in this situation, the test is being modified from a one-tail test into like a two-tail test now. And it's now known that the population variance is 5 cm squared. So this population variance provided by the question is like the so-called the most true variance. So even though just now we have do an estimation for the variance, that one is only an estimation from the data. All right. So this population variance, should supersede the estimation. This is the variance that we will be using directly. Given that the production manager concludes that there is no reason to reject the null hypothesis at 10% of level of significance, find the range of possible values of the sample mean used in the calculating the test statistics. So this is a question whereby they have given us the conclusion, and we have to kind of like reverse the process to find some of the unknown. All right, so we are going to write down the standard steps as similar to this one first. So in this case, I will just say H0 will be mu equal to 10, and our H1 in this case is not equal to 10. I'm going to perform a two-tail test at 10% level of significance. Okay, and again, under H0, since n equal to 80 is large, by central limit theorem, our bar x in this case will be a normal distribution, so it will be a 10. So for the variance in this case, we are going to make use of 5 already. So it's equal to 5 over 80 approximately. Okay, so for this case, we know that we are not going to reject H0. So in order to do that, we're going to sketch for us a normal distribution to illustrate the situation here. Because it's a two-tail test, so 10% level of significance, 10% is being split half-half to the left tail and the right tail. So here is 5%, which is 0.05, and this is 0.05 also. Okay, and what we are going to do, we're going to come up with our z-test. Right, so the test statistic, okay, which is the z-test, is given to be bar x minus mu over sigma over square root n. Right, so this is the standard formula for our z-test. And for this case, let me just rewrite this to a small letter, small x. And this bar x is the value that I want to find. So this mu, will be equal to 10 here. And for this case, the sigma will be equal to 5. So it's 5 over square root 80. And we can see in order for you to not reject H0, that means to say, this test statistic value should fall within the non-shaded region, because at this critical region, right, is led to the rejection of H0. So in this case, we are not supposed to reject. So I know that this value should fall within this range. And by using our inverse norm, we can compute out this value and this value. This is like minus 1.6449, and this is 1.6449. So in order not to reject, this value should fall within this. Let me continue my working here. So I know that my bar x minus 10 over 5 over square root 18 should be between minus 1.6449 and 1.6449. Right, so for this case, if we were to simplify this, I will end up with an answer of bar x to be between 9.5888 and this will be 10.411. And if we were to give our final answer to 3SF, this will be my answer, which is between 9.59 and 10.4. So this will be the final answer that I required for my bar x not to reject H0. Let's take a look at question number 11, which is a kind of discrete random variable question meshed together with binomial distribution. We have this one period binomial model and the stock price is initially at S0 and it either rises to U S0 with a probability of P or drops to 1 over U S0 with a probability of 1 minus P. And it's given that U is greater than 1. So I will know that in this case, this definitely is more than the original one. This will be less than the original one because U is greater than 1. Suppose we are given some of the information here, S0, U, and P, some of the values. We are expected to show that the expected value of the stock price S at the end of the period is 10.35 and find the variance of the stock price. Okay, maybe I will just replicate the diagram here. So we have S0 here. So P in this case we are given to be 0.55 and this will be 0.45 and U is 1.2 and this is a 1.2 and this is a 10 and this is a 1 over 1.2 times 10. We are supposed to find the expectation and variance for this situation. An easier way to do this, maybe I will just come up with a discrete random probability distribution table first. So in this case, we have like a okay, so this will be the two scenarios. This will be my S, this will be my probability of big S equal to S. Right, so the values that we will be having, right, is either this value or this value. So it's a 1.2 times 10, or it can be a 1 over 1.2 times 10. And to get the probability of this one, we can see it's just 0.55. And to get a value for probability of this one is 0.45. So now we can do our expectation. Expectation basically will just be this times this plus this times this. So I will get 0.55 multiplied by 1.2 multiplied by 10. And this will be 0.45 multiplied by this, which is 1 over 1.2 times 10. Okay, so pressing this in the calculator, I should be able to get an answer of 10.35. And to compute the variance, we are going to make use of this formula, which is variance of x is expectation of x squared minus expectation of x whole thing squared. So we need to find out what is my expectation of s squared first. So expectation of s squared, I can obtain from here 0.55, which is 1.2 times 10 whole thing squared plus 0.45, which is 1 over 1.2, 10 whole thing squared. So this working out, I will get 110.45. So finally, variance of S will just be equal to this minus the square of this 110.45 minus 10.35 whole thing squared. So final answer 3.3275. Okay, and okay, maybe we should continue with part B now. So this question says the above model can be extended to n period binomial model. For each period, the stock price S either rises to US with a probability of P or goes down to 1 over US with a probability of 1 minus P. All right, so actually it's just an extension from the first part. That means it becomes more stages. So we have different periods which represent something like this. Okay, and in the first quarter, the initial price of the stock at the start of the period is S0. And suppose the stock price rises 4 times and drop twice over 6 periods. So 4 up, 2 down. Find the stock price in terms of S0 and U at the end of 6 periods. Okay, so there will be a lot of combination, but regardless of what, right, I know that as long as there's a 4 up, 2 down, right, the stock price will always end up to be the same, regardless of the arrangement of when do you have the goes up or when go down. All right, so let me just write down here. So part 1, so the price will just simply be, if you go up a total of 4 times, so you have like a U times U times U times U, a total of 4 times. So it's like a U to the power of 4. And if it drop a total of 2 times, it's 1 over U squared. And we will be multiplying this. This is like the so-called profit factor. So I'm going to multiply it by the original price. So from here, simplifying, we have a U squared S0. So this will be the final price after 4 up and 2 down. And in part 2 of this question, they say that show that the probability for B part 1 to happen is 15p to the power of 4, 1 minus p squared. So now the question is asking us to come up with all the different arrangements you can have. Like one arrangement I can think of is up, 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 down, down. Or it can be down, down, up, 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 up. Or can be up, down, up, down, up, down. Up, down, up, down. Up, up, up. Okay, all the different combinations. This is what it means. All right, so there are 2 ways of doing it. So maybe the easier way, right, I will just do a permutation. So probability will just be equal to a permutation. So for the 4 up and 4 up, the probability will just be equal to p to the power of 4. 2 down will be 1 minus p to the power of 2. And because there are 6 periods and 4 repeated, 2 repeated, so I will just do a permutation of it, which is a 6 factorial over 4 factorial, 2 factorial. And for this portion here, it will just give me equal to 15 p to the power of 4, 1 minus p squared. You can also think of this like doing 6 choose 4 if you want. Like out of 6 periods, you choose 4 to be the up. So automatically 2 will be down also. All right, so you can also do a 6 choose 2. So we have many choices. So we just choose one that you are more comfortable with. All right, and we are going to look at our part 3 now. So part 3 says that in the second quarter, the initial price of the stock at the start is S1. Find the probability that the stock price is higher than S1 at the end of 6 periods in terms of P. Okay, so now if you have the initial stock price to be S1, after that, right, it will be higher after 6 periods. So if you think of it this way, right, what happens if you have like 3 up and 3 down? Actually, the prices will kind of like neutralize, right? The up is being neutralized by the down. So if you have a 3 up, it's like a u to the power 3. Then 3 down is like 1 over u to the power 3. So kind of cancel out each other and the price remains the same. So in order for you to have a higher stock price after the 6 periods, right, the number of up must be 4 and above. So it can be like 4 up, 2 down, 5 up, 1 down, or 6 up, no down. So these are the 3 cases. All right, so I can do a bit of definition first. I will just write it here. So I will let X denote the number of ups in the 6 periods. So I can think of this like a binomial distribution, right? So we have a 6 period, and in this case, the P is unknown, so I'm going to leave it as a P here. So just now, what we have discussed, you need your number of up to be 4, 5, or 6. So we can use this notation to represent 4, 5, or 6. So I want to find the probability of x greater or equal to 4. All right, there are two ways of doing this. You can either do the 1 minus, or you can just break this up to become a px equal to 4 plus px equal to 5 plus px equal to 6. I think not much difference, so we are going to go for this because the values is not given for the p, so we have to make use of our formula from the MF. The formula from our MF, right, is given to us is the px equal to x equal to n choose x, px 1 minus p n minus x. So we are going to use this formula for each of this term here. Right, so it's going to get a bit messy, right? So I will just write down each of them now. So for the first one will be 6 choose 4, P4, 1 minus P2. For the second one will be a 6 choose 5, P5, 1 minus P to the power of 1. And the last one will be like a 6 choose 6, then we have a P to the power of 6. And 1 minus P to the power of 0 is just 1, so I just leave it like this. Right, so if you just compute everything using a calculator for these choosing terms here, you'll be able to get 15p to the power of 4, 1 minus p squared, plus 6p to the power of 5, 1 minus p, plus p to the power of 6. All right, so this will be the answer for my part 3. In part C of this question, we have this contract that gives investor the right to buy a stock at a specific price at the end of a specific period. It's called the call option, right? So the specific price is called the strike price, and the amount needed to buy this contract is called the premium. And each unit of the stock call option has a return value V at the end of the period, and its value is given to be this table here. I just replicate this table here already. And we also have a stock K, which is currently priced at $10 and is modeled by this particular scenario here, with some of the values given to us, n equal to 6, u equal to 1.2, and p equal to 0.55. And this call option of the stock K has a strike price of $10, all right? And we are supposed to fill in the missing numbers in the following probability distribution table for V, all right, which is given to be this, right? So the scenario is like this. Now we have a stock price that is $10. And this strike price side is like being executed at a future date, which is for this case is after the 6th period, all right? So now, right, there will be a few cases that it can happen to the stock price over these 6 periods. So the first case is they can remain the same. So what happens if it remains the same? $10 initially, after that is $10. So in the end, the value will be actually 0, right? Because there's no value added to the stock. But after 6 period, it can go up. If it goes up, right, more than 10. So now we can use that more than 10 value to subtract away $10. That will be the so-called the value. But anything that is below, let's say initially is 10. After that, everything, the stock price is $10 and below, $9, $8, $7. So it has like a kind of negative return, right? So in the end, the value will always be 0. So this actually will show us, right, this table, right, is number of times stock rises. If it's a 3 or below, right, we know that this will always be equal to 0, right? This is also given by the question is 0. So the value is nothing. Okay, and if it's 4 and above, we just now, previous part, we already discussed already. As long as your there are 4 ups, right, or 5 ups or 6 ups, your final result for the stock prices will definitely be more than the original one. And the 4 up, right, the probability is given by this. 4 up, I mean this is 4, this is 4, 5, 6 is given by this. So to compute the value for this one, right, we know that after it rises for a total of 4 times, right? I can actually make use of this one because this is the price that is 4 up and 2 down. That is from our previous part. This one actually is linked together. So by subbing our VU, right, be equal to 1.2. So subbing in like a 1.2 square, and this is the original 10. So this one, if we work out right, let me just press it now. So I'll get a value of, this is like 14.4. And if we want to compute this V, right, this actually is equal to this 14.4, right? Is the final price. Then minus away the strike price. Strike price is always remain at $10. So this will give me a value of 4.4. And to compute the corresponding probability of this one, actually it's just this part here because it goes up by 4 times. So this P, right, is given by 0.55 by the question. So by subbing in 0.55 here, which is 15, 0.55 to the power of 4, 1 minus 0.55 squared. So this, I will be able to work out an answer of this one will be equal to 0.27795. And for the probability of this one, 3 or below, 0. And I can just use 1 minus the rest, which will give me a value of 0.55848. And now the call options is currently has a premium of $2.50. And Peter plans to invest 10,000 on purchasing 4,000 units. It makes sense because 1 unit is $2.50. If you have $10,000, 10,000 divided by 2.5, you end up with 4,000 units of these call options. And he's going to sell them at the end of 6 periods. Find the expected return value of this investment, giving your answer to the nearest dollar. All right, so just by looking at this, it's logical that we should actually try to find out the expectation of this case first, right? Right. If it's a positive value, that means it's a good investment. If it's like a negative value, then no good. Okay, so I'm going to compute out using the expectation. So expectation of V will just be equal to this times this plus this times this plus this times this plus this times this. Okay, this part no need to write. It's just like 4.4 times 0.27795 plus plus 10.736, 0.13589. Then this one will be 19.85984 multiplied by 0.02768. And pressing this whole thing into the calculator is equal to 3.2316. All right, so in this case, right, we are looking at just like a 1 unit. That means, right, for this 1 unit after the 6th period, you will return like a $3.23.16, which is actually quite good because it's more than the premium I paid. The premium I paid is only $2.50. Right, so now if we were to compute the total amount that the expected return for 4,000 units, right? So the expected return for 4,000 units, right, will just be like 4,000 multiplied by this value, which is 3.2316. To the nearest dollar, I will work out to be 12926. Okay, this is the nearest dollar. Okay, and this is a pretty good value because it's more than our initial investment of $10,000, which they will be asking us in a part 3. Comment on whether Peter should proceed with this investment plan. Right, so yes, Peter should proceed with this investment plan. Right, because the expected return is higher than the initial investment of $10,000 because the expected return is this amount, which is higher than the initial investment. So overall, this is a good investment plan that he should probably consider to proceed with.